Howdy y'all, today I'm going to be showing you the magnetic pendulum. Now right here, I'm going to put this magnetic rod over this blue magnet and predictably it comes to rest over this blue magnet. But if I change the position just slightly, the pendulum goes crazy and instead it ends at the yellow magnet. Now why is this? It's because the magnetic pendulum is a demonstration of chaos in physics. Chaos is the study of unpredictable behaviors within deterministic systems, or in other words, how the slightest change in the initial conditions can cause drastically different outcomes. For example, notice how these two pendulums started in a similar position but ended at two different magnets and had different trajectories. You may notice as the butterfly effect, in which a butterfly in one part of the world can cause a tornado in a different part of the world. Other chaotic systems include the double pendulum, as well as the weather. And because the magnetic pendulum is chaotic, if you were to run a simulation of it on a computer, you can create these beautiful fractals. Fractals are infinitely repeating patterns that exist in both math and physics. Some examples of fractals include the Sierpinski triangle or the Mandelbrot set. In these fractals, each of the colors correspond to a different magnet. If I were to start the magnet over here, it would land at the red area. Now, if I were to go over here at this blue area, it would go to the blue magnet. Now, in between the red and the blue area, there's also a green area. Now, in between this area, between the green and the blue, there's another red area because this is fractal-like. So instead, it will go to the red magnet if I were to start my pendulum here. A possible future development for the pendulum is to create a base that can trace the trajectory of the pendulum. This can be done with using a camera and maybe an LED or a tracking sticker and also a one-way mirror. We could also look to improve our own code for the magnetic pendulum simulation. It can plot the trajectory at certain points, but it does need to be refined, and we also want to find a way for it to create the fractals that we saw before. Overall, that's it for the magnetic pendulum. Thanks and gig 'em.